Okay, so in this video we're going to go over how to evaluate logarithms, or actually two particular logarithms, the common logarithm, what we're going to call the common logarithm, and the natural logarithm. Now we've seen that we can write logarithms of any base, right? But on our calculator, right, we have really only two types of logarithms, right? And that corresponds to these two buttons. All right, so while we can technically write a logarithm of any base, if I want to actually calculate it using a calculator, at least this one here, I think some calculators, especially the Casio, will allow you to just do any bases. But if you have a TI, which I think is usually the most common calculator, we're kind of restricted to really two types of logarithms. Now, when we get into properties of logarithms, we'll see how we can get around that. But for now, we have these two, this log and this ln. Now the first one, this log, is written without any base, right? So it deviates from our standard kind of representation. Now when we see something like this, right, log of just some value x, right, this is what's referred to as the common logarithm. So it is accepted that if you see something like this, what this means is this is a logarithm of base 10. Okay, so if you wanted to, let's say, evaluate something like this, right, this would be equal to, right, the way you kind of do these, especially the ones that you can do without the use of a calculator, right, it's base 10. What exponent do I need to raise 10 to get a 100? Right, that would be 2. So the solution to this would be 2. And we can confirm this on our calculator. We take log 100, and we get to base 2, or we get to the solution 2. Okay, and just in general, if you had a value in the log that was not some power of 10, let's say just 15, right, then you would take log 15, and then you would get a irrational number. And so when it's not one of these whole numbers, what we'll get is a irrational number here. We'll round to 2 decimal places here, 1.18. Okay. Now, if we recall the graph of our basic logarithm, we do see that the values are positive once it crosses the x-axis at 1. So any value of a logarithm that's between 0 and 1, you'll get a negative result, right? So log, and that is for across any logarithm, right? So 1/2 gives you a negative 0.3. Right, or negative 3/10, right? And the closer you get to 0, right, the bigger this value is, right? So we can get log 0.005, and you see how that gets a more negative value. Right now, the output can be negative, but as you recall, the input cannot be negative, right? If you do try to evaluate a negative log, you will get an error, okay, because it's out of the domain, okay? All right, so that is the common logarithm. Now our other special logarithm is what's called the natural logarithm. And as we saw in the exponential section, right, the natural logarithm, that number e kind of naturally arises when we're trying to do that compound interest. So the natural logarithm has this notation. Right, so we read that as the natural log, or log base e. Right, so that's equivalent to log base e of x. Right? And to evaluate this, right, the technique is the same, right? Using a calculator, we want to take the natural log here of a value, let's say 5. And so the natural log is right here, natural log 5, and we get 1.61. And it still follows the same rules as logs, even though we have a different notation here. Base and then natural log of e, that would simply be 1, right? you raise e to the first power, you get the value of e back, and we can see that natural log e, and we get a value of 1. And then similar here, if we square e, this should be 2. Okay. All right, and we'll see in the next section that that is not a coincidence, right? And this kind of will lead us into some properties of just logarithms in general, not just natural logarithms. Okay, so those are the two logarithms that we have at our disposal using a TI. Right. In the next section, we'll get how to use these same two logarithms to evaluate logs of any base.